Hey everybody, MacLane, Wilkinson, and Michael Eggeroff from ZeroDB here. Thanks for joining our very first ZeroDB Community Hangout. These will be bi-weekly, so twice a month, regularly scheduled, just updates on the status of the ZeroDB community, updates on ZeroDB core, how we're thinking about product roadmap and what the future is going to look like, and then just updates of what we've been up to the last couple weeks. So what we want to do today is to tell you a little bit about ZeroDB, walk you through what it is, how it works, why it's different, and then we'll touch on some of the existing contributions we've gotten from the community, as well as look at some areas we think are very interesting opportunities for people to get involved with ZeroDB, either working on the core repo or building around the ecosystem. So to start, ZeroDB is an open source end-to-end encrypted database. What that means is we actually give you a way to operate on encrypted data. So doing things like searching, sorting, sharing with third parties, simple joins, range queries. We can do all of that without ever sharing the encryption keys with the database server. So on this picture on the left, you can sort of see how things might look with just basic encryption at rest. So let's say you have an Oracle server or a SQL server. You can, of course, encrypt that. The problem comes when you actually want to query that encrypted database. You'll have to share the encryption keys with the database server. And in sort of a cloud context, remote context, this doesn't make a whole lot of sense because obviously at that point you're exposing all of the underlying data to the cloud provider and potentially to an attacker who's able to hack inside of that cloud provider. And on the right is how is basically what we do with ZeroDB. So we remove that server-side data breach or data window for a data breach. Even if someone was sitting inside of that remote database instance and observing everything, all they would ever see is encrypted gibberish. So we enable you to do all the queries you need to do without ever sharing the encryption keys with the server. And then we also have this complementary piece of allowing third parties to query your data as well. So these could be other people that need to work on your data, or potentially third-party analytics platforms or things like that.
And a little bit regarding how it works. So there are some other projects other than ZeroDB which work at encryption layer. So they use some encryption which preserves a little bit of functionalities. For example, deterministic encryption and auto-preserving encryption. And ZeroDB actually uses neither of those by default. And if you compare two approaches, function preserving algorithms, let's say if you use deterministic encryption, you just replace your plain text words with ciphertext and match ciphertext with what you are looking for, with ciphertext for what you're looking for. So every time you encrypt the word hello with deterministic encryption, you get the same ciphertext, and then you can match multiple ciphertexts. But in ZeroDB, we apparently don't do that. We use just standard probabilistic AES-256 in GCM mode, but we actually can use any encryption algorithm you plug in. And how actually ZeroDB works is we work at the protocol layer, or you can say at the index layer. So basically, when we create encrypted indices, they are represented as B trees, and basically each bucket of this of each B tree is encrypted on the client side before it goes to the server. So when a client tries to find something, it actually traverses the B trees by downloading its buckets to the client and decrypting and figuring out which buckets to request next. So basically, let me give you an example. For example, we have an index for like full keywords, and we are looking for a keyword mirror. So when you have an index built, you download the root of this tree, pull it to the client, decrypt it, figure out what branch of the tree to pull next, request it from the server, pull it, decrypt on the client again, figure out what to request next, and so on until you get to the very bottom of the tree where the result resides. And so basically, the only information you are opening to the server is which encrypted blocks you downloaded, but you don't show the server what is inside these encrypted blocks. So basically, what the server sees is request to give block with ID number 1, for example, and then the server gives the block. You request the next block, which is probably a child of that. You get this block back to the client, and so on until you get to the very bottom. And that is, of course, all good. The server doesn't know what we'll be looking for, but we have these multiple round trips. So, and the way how ZeroDB works, it caches records which it already requested until the cache fills up. And basically, the records which are not the records, the branches which you request most often are at the top of the tree. So basically, you are essentially caching the top of the tree. But this is all about end-to-end encrypted querying, and we don't only do these simple keyword searches. We actually also do full text search, which and we've made very good improvements of that recently. So you probably can check that out on our GitHub if you are curious, or just install ZeroDB and check it. But this end-to-end encrypted querying is not the only thing we do. Apparently, we also can share data with, or I would say you as an owner of the data can share data with third parties. So without ever sharing your encryption key. The way it works, imagine you have your own key pair and somebody else has their key pair, and you want to give this somebody else access to your data without exposing your private key. The way you do that, we use a class of algorithms called proxy re-encryption. And the way they work, you take third parties' public key, your own private key, and calculate a special function called transformation key. When you send it to the server starts being able to convert data from being encrypted for you into being encrypted for third party you shared the data with. But after this transformation key expires, that third party cannot query your data anymore. Interesting thing is that this proxy re-encryption algorithm is very well shareable, very well pairable with our query protocol. So we can actually share a subset of the data which is matched in some query with third parties. And you can check that out in our white paper.
Thanks, Michael. And now we'll touch a bit on some of the key contributors that we've had already helping out with ZeroDB. So I'll let Michael walk through a couple of those, and then I'll finish up.
Right. So basically, the most technical contributions we started getting from Shui Yu, and what he did, I think the biggest problem we had when he started contributing was performance of our encryption algorithm AES-256 in GCM mode. We chose it because it's hardware accelerated and Intel processors can do it fast. And we used a PyCryptoDome library for this to do this encryption-decryption. Apparently, PyCryptoDome introduced a very high overhead of 250 microseconds to basically initialize the block cipher. So, and we we do that every time we start encrypting or decrypting a new block, and basically it actually limited performance of our queries. And what Shuya did, he actually created a package which uses libsodium to do AES-256 in GCM mode encryption decryption. He wrapped it in Python and pushed this package to pip, and this overhead of creating the block cipher was reduced from 250 microseconds to 5 microseconds. So our encryption decryption became much faster, and it's now far not the bottleneck of the performance. Also, Shuya worked a lot on making indices more performant. So he has made field index more performant. The way this field index worked before was actually inherited from ZoB catalog, and the way it worked was to have a tree for basically values of the field, and for each value it had a subtree of elements which have indexed attribute equal to this value. So basically, imagine you had you record prices for some stock option, and if you have only one value for this price, you apparently created the whole tree for this value. And this occupied a lot of space on disk, and this costed a lot of performance. So what Shuya did, he basically made it so that these subtrees are created only if there are more than 10 elements with this value of the attribute, and if there are less, everything is stored in the parent tree. Oh, and also Shuya made it so that the objects, the data is re-indexed as you update it. Before his contribution, actually you had to manually call the re-index method to re-index the record you just updated. And now you don't really have to do that, because as soon as you update something, it will schedule re-indexing for the commit time. And this was not everything Shuya did. He also did some bug fixes, and yeah, so he's just a very awesome contributor. Another contributor I really wanted to thank is Mixture. Sorry if I pronounced it wrong. What he did, he very quickly ported whole ZeroDB to be compatible with Python 3.5. And this was actually a lot of work. I know that in large corporations, such work with such amount of code could take like 2 weeks, and he did it in just 2 days. He also ported repos.catalog, which ZeroDB depends on, to Python 3, and cleaning dependencies on the way. So it was really awesome. And just before doing that, he created a ZeroDB Haskell client using our JSON API. So if you're a Haskell fan, you probably want to check that out. His GitHub. And of course, he also contributed a lot of bug fixes. Also, want to thank Stefan Holek, who implemented encryption in transit for ZeroDB. The thing is that with ZeroDB, the server still learns how often you read each block, and that's probably not the information you want to expose to everybody on the network. So just as an extra security measure, he wrapped our encrypted blocks in another layer of encryption, which is basically SSL. So now ZeroDB is not only encrypted in use, but also on top of that encrypted in transit using SSL. And I've touched a little bit proxy re-encryption algorithms. And basically it appeared that all the algorithms we tried to use were written by this awesome scientist, David Nunes. Did his PhD in Malaga, Spain, and now he's a postdoc over there. So if you want to play with proxy re-encryption algorithms, just you can go to his GitHub account, and he has basically 2 proxy encryption algorithms over there. One is the one we mentioned in our white paper called AFGH, and there is another one which is based on NTRU. So it's not only fast, it's also quantum proof, but there are some challenges with proving its correctness. Still, it's all very interesting. And David discussed a lot with us how to improve ZeroDB and how to apply all the hottest cryptography research to make it possible to build secure applications and to make secure computations.
We have a few more people that we want to thank in the community. So Ahmed Ali, who is the founder of CodeM, which makes basically shareable online coding environments so you can just hop into a browser and try something out really easily. So one, I'd recommend to check that website out, codem.com. It's definitely worth a look and pretty cool. But he created an online environment for ZeroDB. So you can just go to their website and search for ZeroDB, and that'll come up. And then the last, but certainly not least person we wanted to thank is Oliver, who put ZeroDB into a Docker container. So that makes it obviously super easy to just spin up a ZeroDB index and try it out instead of having to wrangle with pip install and figure out dependencies and things like that. So those are the people in the community that have been working hard to make ZeroDB better already. And then we also wanted to talk a bit about some of the things on our roadmap that we think could be interesting for the community to work on if you're interested in getting involved with ZeroDB. So Michael will talk a bit about some of our ideas there, but also, of course, we'd love to hear from you guys in terms of what might be interesting, that we haven't thought about that could be a cool addition to ZeroDB.
Yeah, I think what everyone thinks about is how to build end-to-end encrypted applications. So how to actually leverage this capability to have end-to-end encrypted database. And here are some thoughts, and they obviously require implementing this. So one thought is that it's actually not very hard to get ZeroDB working in Chrome browser. The thing is that Google has this native client technology which allows you to run native code in the browser, and Python was ported to Google Chrome this way. So you can find out that you can actually run real Python in the browser, not even through JavaScript, but the real binary Python. And over there, you can certainly run ZeroDB. So it's possible to write Chrome extensions which use ZeroDB and which talk to the server without the server knowing anything. So writing end-to-end encrypted applications this way. Another interesting idea we've got from some people in community is using ZeroDB with Electron framework to build desktop end-to-end encrypted applications. And in Electron, you write desktop applications using Node.js. And actually, what is possible to do is, and it's not very hard, to run ZeroDB API server, which is actually ZeroDB client, which serves JSON simultaneously with the time when you run this Electron app. So Electron app talks to the JSON API of this client server, and this client server talks to the actual end-to-end encrypted manner. So, and this API server can be bundled together with Electron application, so that it's like packaged as if it is one app. And for the end user, it would look like just like one binary, which actually, in fact, runs Node, runs interface written in JavaScript, and ZeroDB API as a client to talk to the server. Also, it's apparently not very hard to make ZeroDB usable by Java applications. And that's all thanks to Jython. So you can actually run ZeroDB using Jython. The only thing which has to be done for that is to write plugins for our pluggable encryption, which use encryption primitives in Java rather than in Python libraries, because their standard Python encryption libraries are not available in Java. They are all sitting in Java namespace. But other than that, our code seems to be compatible with Jython. So it's possible to just run it with Jython or make a jar file using Jython, and this jar file can be used by Java programs. So you could use ZeroDB in Java as if it was not Java but Python. All right, and also what would be still good is to get ZeroDB working in the browser. So, and the way it would work, we would want to get ZeroDB running in JavaScript. So one would think that you need to rewrite it in pure JavaScript for that, but apparently it's not necessary. It's possible to use PyPy.js so that you can run the same Python code in the browser. And it has some challenges, we would need to have all the code written in such a way that it is asynchronous, even in Python, and that's why this work is actually not very trivial. But if you have some ideas about that, you can jump to our Slack and tell us. And also, one of other things which are on our roadmap is achieving perfect security for ZeroDB. Today, even though ZeroDB is end-to-end encrypted, it's not perfectly secure, because you can see which blocks on the server you read more often, and this could probably open up some information to attackers, and we can actually hide even that. So this concern was mostly raised by scientific researchers, but I think it's quite valid. So and to mitigate this concern, we would need to use something called oblivious RAM. So it is a technique when every time you read something, you write something back to the server, and the server doesn't actually know which exact block did you read. And there are this research topic of oblivious RAMs is very hot, and they just become performant enough to be used in practice. So we can just plug them into our working ZeroDB core.
Okay, awesome. Thanks, Michael. So that was most of what we wanted to cover. If you are interested, definitely try it out. Pip install ZeroDB-server. We'd also have to let you hop into our Slack and join the conversation there. We're quite active. And then, of course, you can just clone the repo at github.com/0-db if you'd actually like to contribute. So now I think what we're going to do is open it up to questions. I know some of you are on, and we're happy to chat about whatever's on your mind.
All right.
I think if you guys want to send us questions in the chat, everyone should be able to do that, I hope. Or in Slack, we're watching that as well. So whichever one you're in, feel free to send stuff across. Okay, so first one, I guess, is how does this compare to CryptDB, which is actually a question we get quite frequently.
Yeah, so with CryptDB, basically the CryptDB is research from MIT, and the way it works, it uses combination of multiple function-preserving algorithms. So basically deterministic encryption and order-preserving encryption. So, and when you want to use one or other, you open up this information to the server. So CryptDB is obviously not perfectly secure, but it serves the purpose for some use cases. And with ZeroDB, we don't open this information to the server. So ZeroDB is in principle much more secure than CryptDB. And if we implement, when we implement oblivious RAM technique, then it will be, I would say, even ultimately secure.
Yeah, and I guess the other difference is CryptDB sits on top of SQL, whereas ZeroDB is a document store, sort of similar to MongoDB, except obviously encrypted, and it is ACID compliant as well. So that's another difference. Let's see. Question about key management and how we approach that. So if we have our own key management, things like that.
Mm-hmm. Yeah, so of course, we have pluggable encryption in ZeroDB, and it is possible to just plug in key management system at the client, so that the client decrypts blocks from ZeroDB using any key management system you want.
And I guess we can also, if you just want to have a toy app or start an app, for consumers, you could derive a private key from just a passphrase that people enter as well. So that's another option.
Anything else we got?
We'll leave it open for a while in case there are any more questions. I know a lot of people ask about using it with existing SQL databases like Oracle, or even, I guess, non-SQL databases like MongoDB, or if ZeroDB is its own sort of standalone thing.
Yeah, so yeah, that's a very good question. I think I can actually see how to use ZeroDB with some existing relational database, for example. So imagine you have some sensitive and non-sensitive fields in this, I'll say, MySQL database, and you have primary keys over there. Let's say a primary key, which is just a counter, and let's say you want to query the encrypted fields, which are sensitive. So you can create a ZeroDB index, which allows to search over these encrypted fields. But instead of pointing to Python objects, it will basically, instead of these pointers, it will basically store the primary keys for the records in the relational database. So you do your query on encrypted fields through ZeroDB, and the server is, for example, co-located with your MySQL server. And when you find in ZeroDB where are the records you want to find, you will see the IDs of these records and get them from MySQL.
And I guess that would be another interesting place for people that were interested in contributing to get involved there. Okay, I will. Any last questions? Otherwise, we will wrap it up. Of course, we are always on our Slack, so if anything comes up after the Hangout is over, you can definitely find us there. ZeroDB.io. The Slack link is just on pretty obvious. So just click through and you can join that way. All right, if that's it, we will finish up. Thank you all for your time and joining. Again, this is going to be a regular thing, so the next one will be in 2 weeks, and we hope to see you again there and give you updates on hopefully some new contributors that have gotten involved in the ZeroDB community. Thanks, everybody. MacLane and Michael, adios.